In order to avoid having an overly complex and lengthy video over ionic bonds on my channel, I've decided to split this topic into a three-part series. Part 2 of this series, the video which you are watching right now, will lecture on naming and writing for both simple and complex ionic compounds. For an introductory video into what ionic bonds are, please watch Part 1 of this series. Let's get right into it. Something I'm going to clarify before jumping in. Simple ionic bonds are bonds that exist between a metal and a nonmetal, while complex ionic bonds exist between a transition metal and a nonmetal. Let's begin by learning how to write the notation for simple ionic compounds, starting with the compound sodium chloride, commonly known as table salt. To start, let's break this down into its individual elements. Sodium, Na, and chlorine, Cl. Sodium is in the first group, and thus has a charge of +1. Chlorine is in the 17th group, and so it has a charge of -1. Because of this, these two atoms will combine in a 1-to-1 ratio to form the compound NaCl. What we would do in this step is take the charge of sodium and cross it over to the charge of chlorine, and then take the charge of chlorine and cross it over to sodium. So writing our sodium atom again, the charge from chlorine would come down here after crossing over and form a subscript 1. And writing our chlorine atom again, the charge from sodium would come over and form a subscript 1 for chlorine. If we then combine this into Na subscript 1, Cl subscript 1, because they both have the same subscript 1, it's redundant. And so we can just write NaCl. This is the chemical formula for sodium chloride. Now let's repeat this time writing the chemical formula for magnesium chloride. Again, we start by going to the periodic table and finding our elements. Magnesium has notation Mg, and chlorine, again, Cl. Because magnesium is in the second group, it has a charge of 2+. And because chlorine, again, is in the 17th group, it has a charge of 1-. In our next step, we take the charges of each atom and cross them over. The 2+ goes to chlorine, and the 1- goes to magnesium. Doing so, we find that magnesium will have a subscript of 1. Chlorine will have a subscript of 2. Combining this, we have Mg1Cl2. And again, a 1 is always redundant. You really shouldn't be writing that, so we can just have it as MgCl2. This is the chemical formula for magnesium chloride. To practice, I want you to now write the chemical formula for sodium fluoride on your own. And to help you, I've written down the 3 steps here on the side of the screen, which you can follow. Try writing it on your own, and then come back. We'll work through it together. So, step 1, find the atoms and their charges. Sodium has chemical symbol Na, and fluorine F. Sodium, because it's in group 1, has a charge of 1+, and fluorine, because it's in group 17, has a charge of 1-. In step 2, we will cross over the charges. So the sodium charge will cross the fluorine, and the fluorine charge will cross the sodium. This will give us a sodium with a now subscript 1, and a fluorine with a subscript 1. In step 3, we'll finally combine these two atoms, Na subscript 1, F subscript 1, and cross out redundant charges. Because they both have a subscript of 1, we can cancel these subscripts out and just have our final answer of NaF being the chemical formula for sodium fluoride. Now, let's learn how to name simple ionic compounds. Ionic compounds are named with the cation, our positive atom, in front, followed by the anion, our negative ion. For simple ionic compounds, we end the anion in "ide." Sodium chloride, magnesium chloride, they all end in "ide." So, with this in mind, what would be the name of the compound CaCl2? Again, our cation is our positive ion. That's the one that comes first. In that case, it's Ca. Ca is the symbol for calcium, so we simply write calcium. Cl2 is our anion. That's our negative ion. Cl is the symbol for chlorine. But because chlorine is our negative ion, we need to add IDE, ide, to the end. So we would just remove the "ine" and add "ide" instead. And so the name for CaCl2 would be calcium chloride. And naming simple ionic compounds is literally just that simple. You just take the name of the first ion, the name of the second ion, and then you add "ide" at the end. To practice, try naming the chemical compounds NaBr and BaO. And as you should have seen, Na is the symbol for sodium, Br for bromine. We replace the end and we get sodium bromide. Ba is the symbol for barium, O is the symbol for oxygen. We replace the Y-gen and we get barium oxide. You now know how to name and write the formulas for simple ionic compounds. Let's move on to complex ionic compounds. As their name suggests, this is going to start getting a little bit harder. Remember that complex ionic bonds are bonds existing between a transition metal and a nonmetal. What makes these harder to write is that transition metals do not have predictable charges. With all other elements on the periodic table, we can just look at what group they're in and then figure out their charge. But transition metals really do not have this. So let's start by figuring out how to name these compounds. Let's say that we're given the compound CuCl. We need to know the charge of each one of these ions, because we can't just write copper chloride. To represent the charge of copper, a transition metal, we need to use a Roman numeral after the cation. Chlorine is a nonmetal. It's in group 17, and it always has a charge of -1. Because this compound, CuCl, has no subscripts, we know that their subscripts must have canceled with one another. So that means copper must have had a charge of +1. We now know the charges of each one of these ions, so we can now name the compound. To name a complex ionic compound, we first write the cation, and then write a Roman numeral after it signifying the cation's charge. We then write the anion and replace its ending with "ide." So let's do that with CuCl. We'll first write the cation, in this case copper, and then the Roman numeral for its charge, in this case a Roman numeral 1. We'll then write our anion and replace its ending with "ide." And so our final answer would be copper 1 chloride. Let's now name the compound PbCl4. And I've written down the steps on the right side of the screen. We need to start by figuring out each ion's charge. And something I really want you to realize, just because complex ionic compounds don't have predictable charges, the rules for charges are still the same. We still do all the crossing over, we still add an "ide" to our anion. You really gotta know that. So because of that, we can do a nifty trick, which I just call reverse crossing over. PbCl4 is our final product, but we could also just take the implied subscript 1 from lead and the subscript 4 from chlorine and cross them over again. And in doing so, we would end up with Pb4 plus Cl minus. Reverse crossing over is a really great way to find the charges of each one of your ions when it's in a compound, and I want you to be comfortable with performing it. And now we can just go to step 2, writing it. We would just write our cation, Pb is the symbol for lead, and then we'd write the Roman numeral denoting its charge, in this case 4. We would then write our ion and replace our ending with "ide." And so our final answer would be lead 4 chloride. Let's practice by naming COBr2. And sorry for kind of glossing over it, but I'm going to use the reverse crossing over trick again in this one, just so you get a better understanding of how it works. This copper has an implied charge of 1. So we can take its 1 and cross it over to the bromine, and take the bromine's 2 and cross it over to the copper. And in doing so, we see that the copper gets a charge of 2 plus, and the bromine a charge of 1 minus. And so now, because we know the charge of each ion, we can write down its chemical name. We start by writing our cation, in this case copper, followed by the Roman numeral denoting its charge, in this case a 2. And then we would write down our anion and replace its ending with "ide." So the chemical name for COBr2 would be copper 2 bromide. Alright, you now know how to name complex ionic compounds. Let's move to the final part of this video. How do we write their formulas going off of a name? And for this example, we'll be using lead 2 bromide. And the steps are exactly the same as with simple ionic compounds. We want to find the charges of each ion. We then want to cross over these charges, and then we want to cancel out our redundant charges. Because lead has the Roman symbol 2 following after it, we know that lead has a charge of 2 plus. Bromine will always have a charge of 1 minus, because it's in group 17. We then just take each one of these charges and cross them over with one another and get a final answer of Pb subscript 1, Br subscript 2. And because the 1 is redundant, we can cross it out, and our final answer is just Pb Br 2. And just as one last practice to wrap up this video, write the formula for the ionic compound iron 3 sulfide. Iron is a cation, and we know that it has a charge of 3 plus due to the Roman numeral 3. Sulfur always has a charge of 2 minus because it is in group 16. We then take each one of these charges and cross them over with one another, and our iron gets a subscript 2 and our sulfur a subscript 3. We have no redundant charges to cancel, and so our final answer is just Fe2SU3. And congratulations! That's everything about naming and writing both simple and complex ionic compounds. I know this was a ton of information to take in. I'm sorry if any of it was confusing. If you're struggling with any of this, just try rewatching parts of the video. If it's still not making sense, just take a break and come back later. As always, if you have questions, please post them in the comments. I will provide my best answer. Thank you so much for watching.